Good morning and once again welcome to my YouTube channel, Pearson at Excel International Maths by Mr. Kamotho. And today, the 9th of September 2020, I want us to discuss something to do with area of a segment. And we are discussing Pure Mathematics 1, IAL International Advanced Level, and we are still in topic number 7. And we are winding up with example 10. 11 and 12. And what we need to understand is that using radians, as illustrated on page 140, you can find the area of a segment by subtracting the area of a triangle from the area of a sector. Let me just have the diagram so that we can see what we are talking about. That is a circle, and that is a sector, and this is O, and this is point P, and this is point Q, and this is the radius. And you'll see that if we can drop a chord there, then from the segment OPQ, from the sector rather, OPQ is a sector, we would wish to find the area of that minor segment, and it goes without saying, this is simply area of segment is given by area of sector OPQ, the sector OPQ, minus area of triangle OPQ. Okay, I wish probably to name name the sector differently. OP. Let's talk about. We could also have another Q there, or rather R there. OPRQ, so that the sector itself is visible. OPRQ, that could be the sector, and the area of the triangle OPQ, so that we don't name the triangle the same way we named the sector. But we know the area of a sector, it's simply area of segment, therefore it becomes the area of a sector is a half r squared theta minus the area of a triangle. Earlier on, we have understood that the area of the triangle to be a half AB sine theta, or a half r, and then the sine of theta, which is the angle in between the two given sides. A half r squared sine theta. That is the area of triangle OPQ. And it goes without saying, you can already see that a half r squared is common. So area of segment becomes half r squared, open bracket, theta minus sine theta. And that is just like it, where theta is in radian form, angle in radian form. And without further ado, let's talk about example 10. In example 10, on page 141, the diagram shows a sector of a circle. Find the area of the shaded segment. The sector of a circle looks like that, and this is now the shaded segment. This is 1.2 radians. This is 7 centimeters, and this is another radius 7 centimeters. And the area of the shaded region is very simple now. We just have to apply the formula. Area is equals to a half. R squared is 7 squared, open brackets, theta, which is 1.2, minus sine 1.2 radians. This is now the work of the calculator, because we need to talk about the calculator in radian mode. We have to put our calculator in radian mode, and what we have is, let's have 1.2 minus the sine of 1.2. Let's just see what that gives us. And then you multiply this one by 7 squared, which is 49, which gives you that. And of course, you divide this by 2, or multiply by a half. So divide by 2, it gives us 6.565. 6.565, which is 6.57 centimeters squared. If we are talking about very significant figures. So that is it, and that is as far as example 10 is concerned. And I think in the same video we can try to explain example 11. Let's talk about example 11 on page 141 again. And in example 11 we're given a diagram that looks like this. This is a sector of a circle, and this region is shaded. The segment is shaded. That is center O, that is A, that is B, this is 5, this is 4, this is 4. And in the diagram above, OAB is a sector of a circle, radius 4 meters. The chord AB is 5 meters long. Find the area of the shaded segment. Find the area of the shaded segment. Now, it is important to note that we do not have the theta, we don't have the angle, and we have the opposite side, which is 5. And yes, it hits to us that we can use either the sine rule or the cosine rule, because we are told that 5 squared is equals to 4 squared plus 4 squared minus 4 times 4 cosine theta. And that one takes us somewhere, because we know a squared is equals to b squared plus c squared minus 2bc, the cosine of a. We can now use the cosine rule here, because if this is O, then this side is small o. That means that according to how we know it, the cosine of A, for example, we are talking about theta there, as far as making this one the subject of the formula is going to be b squared plus c squared minus a squared over 2bc. And then you can already say the cos, shift cos to find the value of A. So it goes without saying that the angle AOB, or rather the cosine of angle AOB is going to be given by 4 squared b squared 4 squared plus 4 squared minus 5 squared, everything over 2 times 4 times 4. Just apply the cosine rule there. And we are told that if you use the calculator properly, you may get 7 out of 32. That is 7 out of 32. And therefore, A is given by the cos inverse of 7 out of 32, which is about 1.3502 radians, of course. Having found that, we need now to find the area of the shaded segment, which means the area of shaded segment is the area of the sector a half r squared, which is 4 squared, and then Inside the bracket, we have the theta 1.3502 minus the sine of the same 1.3502. And of course, using the calculator, you realize that this is simply going to give you a 3.00 meters squared. This is to three significant figures. Find out whether that is what you're going to realize, because again we can you can also use your calculator. 1.3502 minus the sine of 1.3502, and you get that. Then you multiply by 16, you get that, and then you divide by 2, you get 2.995. Of course, this is true, 2.995, and to 3SF, then we are talking about 3 meters squared. And at the end of the day, that is it. Please again visit my YouTube channel, Pearson and Excel International Maths, and subscribe and share widely, and let's see what we can achieve.